Okay, we ever take a quick algebra problem? We've got x plus 3xy plus y equals 13. And we need to solve this when x and y are just members of the positive integers. Now, one way you could do it is you could probably just guess and check the answer. And that's probably not too bad, but I want to do it systematically to try to cover some different scenarios. What if we had different coefficients on this? So the process I like to use for this is to group two of the terms and factor out what's in common. So like we could group this right here and just factor out x, and then what we get is 1 plus 3y. Everything else will just kind of copy over. And then for step 2, I want to turn this y, I want to make it look like this right here. The way we can do it first is multiplying in by a 3 on both sides. Multiply by 3 here, multiply by 3 here. When we do it, we're going to get 3x times 1 plus 3y. Over here, this thing's going to be, I'm going to give some space because I'm still trying to match this. So that's going to be a 3y. And then here we just have 39. Then again, if we want to match that, all I need to do is add a plus 1 on here. So just kind of adding it in the middle there. Don't want to change it, so let's add 1 on the other side. But now we have this term in common on both these things here, so we can factor it out. So I'm factoring out 1 plus 3y. Doing it, kind of reorder it, so I could do it 3x plus 1. Let's write it as 1 plus 3x, whatever. And then adding this together, we get 40. And this is where we're glad that we've got this as all integers. I mean, it would be all, I think it'd be an infinite number of solutions anyway, but because it's integers and positive integers, it's gonna help us narrow this down. Because what we can do is factor 40. Can do all the factorization, so we can have 40 times 1, 20 times 2, 10 times, I was going to do 10 times 3, but no, it's 10 times 4, and the last one's going to be 8 times 5. And now, of course, I could keep going and reverse all these, but the thing is, there's this symmetry here where you could just kind of switch the variables and it's not going to matter. So like, for now, we'll assume y greater than x. But if we get a solution, we're just going to be able to reverse any of these cases and just get the opposite. So we'll see how that works at the end. But now let's just deal for now with these 4 cases where y is greater than x. I could do y is greater than or equal to x, but there clearly it's one or the other. It's not a perfect square. So starting with 40, the thing about 40 is, again, back to positive integers. If x is positive, and that means it's going to be at least 1, then everything here has to be greater than or equal to 4, because 1 is our lowest x value. So what happens right away is this isn't possible and this isn't possible. But then looking at this case for 10 times 4, the way we can get this is when we want y equal to 3. And to get a 4 here, we just need x equal to 1. And that's going to be one solution. We'll come back and verify these at the end. So then on to this next case, 8 and 5. If we want y such that we get an 8 here, so we're saying 1 plus 3y equal to 8. Just solving that, subtract 1. Then with this, if I divide by 3, we get y equals 7 over 3. Trouble with this is we need it to be an integer. That's not an integer value. The same kind of thing is going to happen on this value. Actually, it doesn't even matter, because once we have a non-integer value here, it doesn't matter what's happening here. So this case is gone too. So what I'm saying is we're going to have these two solutions for our x, y. We'll have 1 and 3 as a solution, and I'm saying the opposite's going to work because we can just reverse the variables. But let's verify each of these. So if we plug in to our equation 1 and 3, so we're going to have 1 plus 3 times 1 times 3 plus 3. That's going to be 9 plus 4, or 13. Doing it the other way real quick, now the x value becomes a 3. Same kind of thing, again, 9 plus 4, 13. And so these are our only two solutions. Okay, that's it for today. Thanks everyone for watching. Have a good day.